In this unit on geomorphology, we need to talk about river systems because rivers are a significant agent of changing landscapes through their mechanism of erosion, transportation, and deposition. Where we take matter away creates new landscapes, that's erosion. Where we add material that was removed from another location to a new location creates new landforms, and that's deposition. Several characteristics of rivers need to be discussed in order to understand the landscapes that are formed. So when we talk about landscape formation with the use of water, we consider those fluvial processes. And fluvial processes are driven by two things: gravity. So where water falls on the surface of the earth, gravity then pulls that to the lowest point. So water falling in the Rocky Mountains in Glacier National Park, the highest elevation that we've got for the Mississippi River itself proper, is going to then have that water as it's deposited in a pillow of snow on the top of Mount Sahi or somewhere. As it melts out over the course of the year, it's going to find its way down into particular lakes. And that lake was going to take time to empty, and that water will flow through that lake into the St. Mary's River system. That St. Mary's River is going to eventually connect to become part of the Missouri. The Missouri then connects to the Mississippi, and then the Mississippi empties out into the Gulf of Mexico. Many, many, many days to years are required for this process to take place. And that transportation from that high elevation to the ultimate low elevation, which is the delta of the Mississippi, is possible because of gravity. The second component that's required is solar radiation. We've been talking about exogenic forces that drive geomorphology, and we've talked about exogenic forces that drive the atmospheric circulation and the hydrological cycle. So in this condition, in order to get the water to these high elevations and any elevation on the surface of the earth, we've got to enact that evaporative transportation network by removing water from a body of water, an ocean, a lake, a stream, through the adiabatic process, lift it into the atmosphere, create a cloud, and then have it snow or rain out somewhere. All right, so those two processes are critical in changing landforms, and we often don't think about hydrology as an agent of change for landscapes. Streams ultimately then cause erosion, transport the material that was eroded, and then eventually deposit the material which was eroded. So we've got three zones, and looking at the slide here, you can see the three zones from an area that's mostly removal, but there are conditions of deposition in zone 1, but removal or erosion is greater than the deposition in this first zone. Transportation takes place in here because the rivers and streams and brooks are constantly moving. We've got a middle zone, which is mostly transportation, but both erosion and deposition also occur in this middle zone. And then the third zone has all three elements: erosion, transportation, and deposition, but this is mostly a deposition zone. The largest volume of matter that is moved through a river system is called alluvium. It's composed of clay, silt, and sand, which is carried by a stream, but I want you to keep in mind that there are larger bodies that get moved through streams as well. They usually just get moved when water is at a flood zone, and at that point then we can be carrying cobbles and stones. So the first unit of landscape that we need to consider is the drainage basin, and that's a unit of land that's occupied by what we call a river system. And a river system is a river and all of the little tiny streams and brooks and rivers that connect together that drain a particular landscape. So we've got the Mahoning River here in the Mahoning Valley. It has a number of small streams that collect water on the surface of the earth, channel that water into the Mahoning River, and increase the volume of the Mahoning River by the total volume of area that's drained by those tiny little brooks and creeks. The Mahoning then empties out into the Ohio River, and then the Ohio River is going to empty out into the Mississippi River, and then ultimately into the Gulf of Mexico. So all of these little streams and brooks and rivers and big rivers all are catchment basins or drainage basins, and they're defined by high elevations that control or determine what side of a high point does water in the form of precipitation run off or fall towards. So if you've got a fulcrum at the top and a raindrop, it's going to fall to one side or the other side, and the side it falls on is the drainage basin for that side. With that, I had mentioned that there's tiny little brooks and streams that form together to empty into the Mahoning River. Before the water finds its way into a little creek or a little brook, it starts off as overland or through flow. Overland flow is sheet flow, and you'll often see sheet flow on a road system. It's like a sheet of water that sort of covers the entire road. When that occurs on the surface of the land, that means that the water in the rock itself and in the soil itself is saturated to 100%. When you've got that sheet flow occurring, then that's going to all transport in a unidirection, singular direction into that brook and become a brook system. So this is what happens on a smaller scale, the size of somebody's backyard, the size of the north side of Youngstown, has all these tiny little brooks and streams that empty out into a river. If we look on the larger scale of things, where the entire drainage basin for a continent occurs, we talk about continental divides. And these are extensive mountain or highland regions which direct which way a collective volume of water that has fallen to the earth is eventually going to flow. So we think about these in terms of which rivers empty out into the Pacific Ocean, which rivers empty out into the Gulf of Mexico, which rivers empty out into the Atlantic Ocean, and which rivers empty out into the Hudson's Bay and the Arctic Ocean. So we can then trace all those rivers back upland. So if you were going to go for a long hike and you started out at the mouth of the Mississippi River and you walked all the way up the Mississippi, and you would come to a junction of a river that empties into the Mississippi, you can walk then, take that channel up and walk up that particular river. Let's say we chose the Red River, that is the first really big river that empties into the Mississippi, and that starts in Texas. We could walk all the way across into Texas and find a number of tiny little streams that empty into the Red River, and we would walk up one of those little streams to where we're going to have the stream terminate. You can't find the stream anymore, and that's where the sheet flow is going to be. That's where there's rilling or tiny little rivets on the surface of the earth that channelize into the brook or the stream that's going to empty out into the Red River. If we continued walking up the Mississippi and we decided we were going to ignore all those smaller streams that make up the Mississippi, and we got to the junction where the Ohio River meets the Mississippi River, and we deviated from the Mississippi and we walked up the Ohio River drainage basin, we could select any number of streams and rivers that empty into the Ohio and find their origins as well. So we've got many, many different pathways of river systems that make up a drainage basin that flows into a particular direction. And ultimately, when you get to the apex of any one of these drainage basins, the water then changes direction and empties into a new body of water, the Pacific, the Atlantic, the Hudson's Bay, a different body of water than the Ohio River, than the Mississippi River does. All right. Our big continental divides for the United States and North America are as follows. The Pacific Ocean, all of those rivers are divided by the Rocky Mountains. That is the highest elevation that determines, does the water flow to the east and south and north, or does it flow directly west into the Pacific Ocean? From the Rocky Mountains, moving across the continent, we then have a number of different drainage systems. The big one is the Gulf of Mexico into the Caribbean drainage system, and that clears out a lot of the water. It's divided by the Rocky Mountains on the western edge and the Appalachian Mountains on the eastern edge. And then importantly for us in Ohio, a ridge that is at the top of the state of Ohio, and the north end of the state of Ohio, and then drains southwards. All right, it's not a mountain range, but it's a high enough elevation that delineates water from flowing into the Great Lakes as opposed to flowing into the Mississippi. The Arctic Ocean drainage basin is delineated by several Canadian provinces where the Rocky Mountains are housed, and Alaska. So the water that doesn't flow west from Alaska then flows northeast across Canadian provinces into the Arctic Ocean. Additionally, in the center of the continent is the Hudson's Bay Arctic Ocean drainage basin. It's delineated by the Rocky Mountains to the west, and then all of that land then to in the middle of the central provinces into Hudson's Bay. Finally, we've got the Atlantic Ocean drainage basin. Everything to the east of the Appalachian Mountains is drained by the highest elevation in those Appalachian Mountains into the Atlantic Ocean. So those drainage basins look like this. So we've got all of these individual drainage basins. Here is the Red River that I had mentioned a little bit earlier. So it empties and drains this space with a whole bunch of other smaller drainage systems. Let's take a look at the Mississippi, because that's the big one. We've got the Mississippi drainage basin. There's an upper and a lower Mississippi drainage basin. So this is the Mississippi proper. But the Mississippi drainage basin incorporates the Red River, the Arkansas, the Missouri system. Take a look at how big the Missouri system is. The upper Mississippi and the Ohio, then the Tennessee, all make up this very, very large drainage basin right here, right? The South Atlantic Gulf drains not into the Mississippi, but drains all of these drainage basins through here. So that's a large Mississippi drainage basin that's made up of several smaller drainage basins. And if you take a look at any one of these in Canada, if you so choose, you will find the same thing. Several drainage basins make up one larger drainage basin. So what I want you to take a look at, and I'm not going to ask you to memorize this or anything crazy like that, is this deep blue line through here is the line of the highest elevation that drains everything to the west, which is the Pacific Drainage Basin, from everything to the east, which is going to make up all of these other drainage basins. The Arctic, the Hudson's Bay Drainage Basin, the Gulf Drainage Basin, the North Atlantic Drainage Basin, which is the Great Lakes through the St. Lawrence, and then the Atlantic Drainage Basin. So we've got these delineated lines, this dark blue line, this dark blue line that circles around the Great Lakes. This blue line are all those big lines that are directing water into a particular drainage basin. All right. We can scale this back and look at individual drainage basins for individual rivers. Here are all of the rivers in Ohio. And these are all these little blue lines. Is every creek, every river in Ohio. It looks pretty mad. With that, and what my eye is drawn to is the red. It looks mostly red than blue, but what you're looking at through all of this red and blue, if you look really close, you'll see dotted lines of red here. These are delineating the drainage basins for every single one of these little rivers and little streams. So if you are in if you're looking at this as a large wall map, or if you were in a geographic information systems and you can zoom in, you could actually see all of those different drainage basins and delineate them out like we did with the Missouri River system, or perhaps the Lower Colorado and the Upper Colorado River system. So you've got that. The important drainage divide or continental divide across Ohio lands right here. So it's not a large mountain chain, but it's the highest places across Ohio. Everything to the north of this line drains into the Great Lakes, and then ultimately that drains into the North Atlantic, all right, or the Atlantic if you so choose, through the St. Lawrence Seaway. Everything to the south of this line is going to drain into the Ohio River, and we know that the Ohio River defines the southern border of Ohio. That's why it looks so ragged. And ultimately, the Ohio, as we said a minute ago, drains into the Mississippi, which is going to drain into the Gulf of Mexico. All right. So drainage divides and drainage basins, they go by the same name, so it can get a little confusing, are considered open systems. And so basically what is meant by that is that anything that the river collects is an input into the river. So if it picks up soil, if it picks up rock, if it picks up pollution, it's going to bring that into the river. It's going to transport that through the river, and it's going to deposit it in places along the river and ultimately into the output, which is a particular lake or ocean system. All right. So inputs then are precipitation, the water that fell, minerals, rocks, whatever was in the atmosphere, so pollution, and anthropogenic contents that are things like oil spills that we've created, for instance, or agricultural pesticides and herbicides. The output is the water that was collected, the sediment, and then the anthropogenic contents.